Construction of the Near Surface Disposal Facility, or NSDF, begins with the site location. A bedrock ridge that is 1.2 kilometers away from the Ottawa River provides protection as it is high enough to be well outside of a floodplain and carved into the slope in a forested area to minimize visibility. The NSDF site is approximately 37 hectares, 17 hectares of which will be the Engineered Containment Mound, or ECM. Following Canadian Nuclear Safety Commission approvals, we are proposing to start construction on the NSDF and expect it will take approximately 3 years to complete. Our construction period starts with enabling works. During this time, the site is cleared of trees, and a secure perimeter and a buffer zone are created. CNL is working with several Indigenous groups on a sustainable forest management plan to offset the deforestation. Dust, noise, and vibration management procedures and surface water management features are established to protect the adjacent swamp and woodland areas. Targeted blasting will be completed to remove rock down to the level of the baseliner. Blasted rock will be recycled for use in other on-site construction activities. Following the enabling works, we begin construction of the buildings, equalization tanks, and site services. At the same time, Phase 1 of the Engineered Containment Mound, which includes cells 1 to 6, the southern perimeter berm, and temporary haul road are built. Phase 2 of the Engineered Containment Mound is expected to be built 25 years after operations begin and will include construction of the final 4 disposal cells in the northern perimeter berm. Now let's take a closer look at the design and construction of the Engineered Containment Mound, which includes the berm, baseliner, and cover systems. First, we construct the perimeter berm, which forms the outside edge of the Engineered Containment Mound. It is constructed on stable bedrock from specially selected, free-draining, natural earthen materials that are designed to resist seismic forces and hold back the weight of the waste pushing against it. The liners of both the cover and baseliner systems are securely locked into place on top of the berm below the perimeter road. Next, we install the 13 layers of the baseliner system. Each of the individual layers has been designed and specifically sequenced to contain the waste, collect leachate, which is the water that has filtered down through the waste, and protect groundwater to ensure the long-term protection of the environment and human health. Working our way up through the layers of the baseliner system, we start at the lowest level, which is formed by the secondary composite liner. This layer consists of a compacted clay liner, synthetic clay liner, and a textured high-density polyethylene liner. By using alternating natural and synthetic layers, we will achieve maximum stability and impermeability for long-term protection of the environment. Next comes a sand cushion, a woven textile separator, and a layer of clear stone, which contains the leachate detection system and a pathway for the removal of any leachate that may have passed through the liner above. From the leachate detection layer, we move to the primary liner, consisting of a high-density polyethylene liner and a synthetic clay liner that work together to provide a strong barrier. Above that, a sand cushion separates and provides additional liner protection. Next, we find a woven textile separator and a layer of clear stone with pipes running along the valley of each cell. These perforated pipes collect and channel leachate to extraction sumps at the base of the berm from where it is pumped to the equalization tanks. In the top layers of the baseliner, we find textile and granular stone layers which protect the leachate collection system during waste placement activities. At completion of the 3-year construction period and a commissioning period, the NSDF will transition into an operations phase. Prior to commencing operations and any waste being received, CNL will apply for an operating license from the CNSC. As a first step in the operations phase, a weather cover will be installed over the active cell prior to waste placement activities commencing. The primary mission of the cover is to prevent precipitation from contacting the cell floor and placed waste. Only waste that meets CNL's waste acceptance criteria will be accepted for disposal, and all waste will be placed in accordance with the waste placement and compaction plan. CNL will prioritize waste prevention, reduction, and diversion to reduce the amount of waste that goes into the NSDF. Waste will be placed in small steps to maximize density and reduce empty space, minimizing the potential for future settlement. Once each cell is filled, an interim cover is placed to provide protection of the environment until the final cover is installed. The final cover is placed during the operational phase as cells reach capacity and are closed. It is made up of similar alternating layers of natural and synthetic materials which isolate the waste, provide radiation shielding, create a barrier to intrusion from plants and burrowing animals, and keeps precipitation from contacting the waste. Following closure of the last cells, the NSDF transitions from the 50-year operational period to a 30-year closure period. During the closure period, the focus moves from active waste placement towards long-term monitoring, maintenance, and preparation for at least 300 years of institutional control. 30 years may seem like a long time, but this period ensures the ECM reaches stabilized conditions and that site infrastructure is maintained and decommissioned in accordance with the closure plan. The environmental monitoring program, which includes groundwater and air quality testing, will ensure the cover system, baseliner, berm, and associated components all perform to expected levels before the NSDF enters the institutional control period. Through design, operations, and long-term monitoring, the NSDF project will significantly improve current and future waste management conditions at the Chalk River Laboratories site, providing safe, permanent waste disposal and enhanced environmental protection and stewardship.